In this third lecture, we are going to study excited state. Excited state is quite important in the photochemistry because in any photochemical reactions, the reaction starts from excited states because when the light is irradiated to the molecules, always molecules absorb light, and then the molecules change from the ground state to excited state. So in any photochemical reactions, excited state is quite important. So let's start from the excited state due to the if you have a sigma bond case. So what we are thinking about is now if we have a CC and CC bond was connected was a sigma bond. In this case, as we studied, we have two states of the sigma bond, sigma orbital and the sigma star orbital, which is a bonding orbital and anti-bonding orbitals. And this one, in the ground state, since the electrons, so electrons are given from the both sides of the carbons. In the bonding orbital, you have 2 electrons, which is a ground state. When the light is illuminated, like if so, one of the electrons is excited, and one of the electrons get energy from light, and it is going up to the higher energy level, which is anti-bonding orbital. And then you have excited states, like this one and then this one. So one of the electrons is now in the anti-bonding orbitals. You can imagine like there are 2 ways of putting the electron in the anti-bonding orbital, which is because you know that each electron has a spin state, which is up spin and down spin. So when you move this electron to the higher energy level, you can think like there's a one way is the up way and the other is the down way. And depending on the relation between the electrons existing in the bonding orbital. So in this case, 2 spin of the electrons are parallel, and on the other hand, these are opposite. This parallel case, it is called a triplet state. And if these are anti-parallel, opposite spin, it's called a singlet state. We are coming back to this issue later, but just keep in mind that there are 2 types of the excited state. And also, I want you to remind that you have to be aware that these are one of the molecular orbital. And this set of the electron configuration is a ground state. For example, this one maybe is 0 state. And this combination of the electron configuration, this is called a triplet T1 state. And then this one is S1 state. So we are coming back here later on. So this S is given from the S, and then this one is T is coming from the T. Okay, and similarly, now we thought about the sigma bonds case, but when we think about the pi bond, in the case of ethylene ozone, you have a pi and pi star states, and if the electrons are excited from the pi state to a pi star state, it is called a pi star state. So always when you think about the excited state, you have to decide from where to where the electron is moved. So let's think about the ethylene case and how these kind of states are formed. So let's simply think about like this. So when we think about the ethylene, like C, and in this case, sigma bond and a pi bond. So thinking about the bonding orbital and anti-bonding orbitals, you can have a sigma and pi star and a sigma star state, right? And when they are in the ground state, so two of the electrons are in a sigma bonding orbital, and the pi electrons are in the pi bonding orbitals. And just simply thinking about, if you have one electron in the sigma state, you have epsilon1 energy of epsilon1 of electron. And then if you have one electron in the pi state, the electron has epsilon2 energy. In this case, like total energy is roughly estimated like 2 times epsilon1 plus 2 times epsilon2. And